Oh, no.
I'm just going to say...
Welcome to the Hackaday podcast. My name's Mike Szczys. I'm editor-in-chief of Hackaday.
Hi, I'm Elliot Williams. I'm managing editor of Hackaday.
This is episode 93. Today we're talking about hot and fast Raspberry Pis, a Dr. Seuss drone, M&amp mass metering, and an FPGA tape backup. Elliot, we know the grand prize winner for the Hackaday prize. It is the Byte, a universal input device for people that are not able to otherwise use like hand and arm-based inputs. This one's super cool because it is built low cost. It's actually completely encased inside of an adult-sized pacifier nipple.
I remember seeing that was like among the first design choices they made. And since then, it has a lot of kind of commodity / easily replaceable / kind of reliable proven parts in it that are all off the shelf. And I thought that was really cool.
Yeah, it's pretty neat to see the 3D printed parts that go into this because there are a number of them, but it doesn't look like anything that would be difficult to injection mold if they wanted to do a larger run or to reproduce with your average, somebody that knows what they're doing with a 3D printer. The input device itself has a bite sensor where your teeth are that's pressure sensitive, so you can kind of do like soft click, hard click, soft bite, hard bite, long bite, short bite, those types of things. And then there's a directional sensor like up, down, left, right for the tongue that also works on pressure from the tongue rather than movement. It does also have haptic feedback. So there's a little vibration motor that goes in there as well. And when you go check out the project page on this, I should say it won $50,000 for being the grand prize. Congratulations. But the demo of it is really cool to see it, used to mouse around, drag windows, do the sorts of things that you would normally do with a computer mouse with your hand. But then there are other custom click events that help out. Like, for instance, if you're not biting at all on the bite sensor and then your tongue does up or down, that will do scrolling on the window. The electronics are outside of your mouth as well. So just the sensor is inside, and then it uses basically like a telephone cord with a jack on the end of it that jacks into a board that monitors the sensor. And so they've showed it with, being a USB device. So it's really easy to connect to any computer. But also, since it's open source, if you had custom things that you wanted to do, it's a matter of, getting the microcontroller figured out.
That's what I was getting at before with the kind of commodity aspect of things. They just use a regular phone jack, a regular RJ45 phone jack to plug into the sensor and then to plug into the little microcontroller board. The microcontroller board's just an Arduino. I mean, a lot of things are kind of off the shelf, but then they put enough thought where that thought's necessary, and that's in designing the thing so that it's comfortable, moving it so that you can, do this kind of D-pad on your soft palette up there. I mean, it's a really sweet design. Like I said, we've watched it kind of evolve from the very beginning where it was a little bit unrefined and just kind of a good idea into something that now looks like it's totally plausible.
The other one that caught my eye, so the Hackaday Prize ceremony was the last weekend over Remoticon, and there were another 8 top prizes for the nonprofit partners that we have for the 2020 Hackaday Prize. But I really liked the best wildcard prize, which was a piezoelectric die that you can use on textiles. They call it PolySense. And apparently you used to be able to buy something like this, but the company isn't selling it or isn't making it anymore. And so this team figured out how they could make it themselves and basically uses traditional textile dyeing techniques in order to put patches of this dye in certain patterns on textiles to make sensors. So you might be able to, take like a glove that you would normally wear on your hand and use like tie dyeing techniques so that the dye only got into certain parts. And then those were like 2 different sides of the sensors. And then as you moved your hand, it might stretch those sensors and change the electrical characteristics of the glove you were wearing.
And in the worst space news of this week, one of the primary support cables at the Arecibo Observatory in Puerto Rico has snapped. We wrote an article previously about how Arecibo got hit by a hurricane and is in kind of bad shape. It's this big hanging dish reflector that hangs in kind of a natural bowl in Puerto Rico, and it's held up by a bunch of wires and some pillars, and one more of the primary support cables has snapped. What this means, of course, is that more weight is being carried by the fewer and fewer remaining cables. And that is, of course, going to snowball if things get over the tipping point. So right now they have everybody evacuated from there. They're inspecting the damage with drones. But it looks like it's kind of, one more bad cable snap away from a complete catastrophic failure.
Oh, man. Just think of the value scientifically to this thing. And it's for lack of infrastructure maintenance that we're looking at actually losing the whole structure. That's really sad. I suppose nothing lasts forever, but
I was going to say, I don't know. I mean, it's really old. B, I don't know what it's good for. Some of the people in the comments came out with that line, like, why aren't they putting more money to this? And the answer probably is that NSF knows what they're doing and they've got better telescopes somewhere else that do better science. I mean,
that's a good point.
They know how to move their budget around. They're not dumb. They're astronomers. So it does make me worry that way. I mean, I don't want to see it broken and falling apart either, because it's kind of historic, but B, it's the only thing that can send messages out to space. So it's unique in a way, but right now it's in disrepair. It's been in disrepair since this hurricane. They have not allocated the budgets to fix it. That's a bummer, but it may mean that they've spent that money on more promising telescopes somewhere else.
Yeah, it's too bad because they just planned, I think Tom was saying this week, to do the repair work on it for the damage that was caused 3 months ago. And, it's a financial problem, but it's also a logistics problem. You have, it's in this rainforest, which is not great for all these metal parts, unless you have someone painting it constantly like they do the Golden Gate Bridge. And then if you do need to replace it, they're sending a cable out to replace it. Like, you got to source that cable and then get it there and then put it on the back of a truck. They're not going to like helicopter it into this thing. You got to put it back on the back of a truck and drive it there. And then you've got to have a crew to put it in place. And it's all happening during a pandemic. Not an easy situation. Yeah. Just imagine though, if they don't fix it, it's not like they're going to demolish it. You're going to have this like huge giant superstructure that's going to get taken over by the jungle again.
I don't know. I bet they could auction it off. They could snip some of the wires, stand back, watch it all fall down, and then auction off the panels.
I have a reflector panel on my wall from Arecibo.
Exactly. Yeah, come on. How cool would that be, right?
Well, as if this wasn't the only thing that went wrong this year, it seems like people are frantic to say goodbye to the year 2020. And so, going along with that trend, Hackaday has started a contest this week, the Goodbye 2020 contest. You know how like every year for New Year's, you think to yourself, I should build some blinky thing that counts down to the new year?
I do.
Now you can actually start now instead of 2 days before New Year's and enter in this contest. It's sponsored by DigiKey. And 3 top prizes for it are shopping sprees from DigiKey, $500, $250, and $100.
Last year for New Year's, speaking of last minute, I built my son a disco ball. Or rather, he had the disco ball and I built the spotlight by like scrounging up a whole bunch of lenses from around the house and some high power LEDs and putting them all together. And it was awesome.
Did you have a motor to spin the ball?
No, I had to go up there and spin it by hand every once in a while. And, it spins up for kind of, the ball itself is surprisingly heavy. It was suspended on fishing line, so it spins for a good long time just on momentum alone. But every 10, 15 minutes, I'd have to go give it a twist. Come on, what do you want for instant disco ball?
The example that I put in here, I really want someone to build this, or maybe I should build this. I want someone to rip off the day-by-day calendar, those square pages that you rip off from the desk calendars.
Yep.
And burn them or shred them or something. Don't burn your house down. But yeah, so like an art piece that counts down 365 minutes to the new year by burning all the days of 2020.
Well, there's some latent hostility toward 2020. Someone in the comments, I think the first commenter actually suggested, oh, really? I'll just make a big hand flipping 2020 the bird. The other side of that coin is the hopefulness, looking forward to the future. On the other hand, I kind of want to see a giant animatronic hand flipping a bird. So, I'm willing to accept it.
Sounds like a soft robotics project.
Oh, right? Yeah, I was thinking something, really huge with those like marquee chasing lights going all around the outline of the hand and like like the cowboy on Binion's Lucky Horseshoe on the strip in
Oh
Las
yeah,
Vegas or
the
something,
cowboy
right? Like
waving. Yeah.
really, really glitzy and just a giant finger flipping the bird.
And on that note,
Wait. How was Remoticon?
Remoticon was awesome. Weren't you there?
I was there. I was going to say thanks for holding down the SMD challenge. And it was so super much fun to hang out with the Hackaday crew for our ragtag misfit SMD challenge attempt, for which like half of the team didn't even have the parts. And the winner of all of the unlucky events was Bob Badley.
Yeah, you liked that. So Bob was trying to solder. He was very excited. It seemed he had his kit and he was
He
all
was
set
ready to
up.
go.
Yeah, and then he didn't even say anything. But I was watching on the video feeds, and all of a sudden I'm seeing him like grabbing the tip of his iron.
He's holding the iron in his hand like it's
Yeah.
a baseball bat with the wrong side.
And it wasn't heating up. And then before you know it, he's taking apart the soldering station and taking apart the heating element and measuring it and trying to figure out if he can repair it. And alas, there was nothing he could do. But Jenny List saved our bacon and, completed the SMD challenge all the way down to the 0201, the tiny components.
In a world-beating time of 84 minutes.
It's not how long it takes. It's just whether you got there or not.
I'm telling you, she got it done at all, and that is a total win. Dan put in his personal best. Actually, it was really nice to see, given that the first time he ever did SMD soldering at all was last year at the SMD soldering challenge. For him to be taking that on again is always pleasant to see. I didn't have the parts, so I was just dead bugging some stuff. That was good fun. To be frank, we kind of almost participated in the soldering challenge, but we all had a really good time. So let's talk about some hacks.
Yeah, I got to talk about this binary calculator. This was actually entered in one of the contests that just wrapped up, which is the circuit sculpture contest, which is in judging now. But it is a gorgeous little binary calculator. It has just 6 buttons on it. It has a clear button, a minus, a plus, a 0, a 1, and an equals button on it. They look just like keycaps. The coolest thing though, Elliot, these are milled out of cherry wood. So these are cherry keycaps.
Oh, boo. I didn't even get that.
They're not key switches. They're just momentary push buttons, but the caps are pretty nice. The thing about this is it's just overwhelmingly pleasing. The thing looks like a rat trap. It's about the size and shape of the wooden base on a rat trap. And then because it's circuit sculpture, there's all these brass rods going everywhere that are the traces for the electronic circuit. And they kind of look like the brass parts of a rat trap as well. In the middle where the hinge would be, there's a dead bug microcontroller that makes it all go. And then up on the top, there's a double row of through-hole LEDs kind of hanging out in space, and an LED driver that's an SSOP package, so a surface mount, fine pitch package that's just hanging in midair from a bunch of enamel wire connectors that are hooking it up to the LEDs.
Yeah, this thing is definitely in the artsier side of the artsy versus utilitarian divide. I love the idea of a binary calculator, but I always need a hexadecimal calculator. So I'm a little bit angry about this thing. And then I always need a hexadecimal calculator, and then I always need it to do like ands and ors and XORs and, stupid things like that. And this one's only got plus and minus too. I think he's really missed a trick. I think his next one is going to have to be hexadecimal, and I have no idea how to represent that with LEDs. I realized after I started saying it. Damn it, he's going to have an LCD screen, and that completely kills the aesthetic.
Yeah, it becomes a different calculator. But
don't listen to me, dude.
So finishing up with the cool design parts of this, I thought it was really nice how the base itself is hollow. And so it's hiding a battery inside of it. And then if you look closely, the on-off button is milled into the side edge of the thing as well. So just a ton of you might not notice them at first, little touches that I think make this really special. Oh, and I didn't even mention, it's a binary clock when you're not using it as a calculator. And so Dennis 14A built a bell jar display case for this, so you can have it sitting on your desk ticking away even when you're not using it.
All right, speaking of silly machines, my first hack this week is Harrison McIntyre's "Hey, you left the peanut out of my peanut M&Ms." Candy sorting machines are an absolute classic, and this one takes yet another crazy spin on it. It starts with the premise that some peanut M&Ms are lacking their peanuts. They're made defectively, and he says that this is about 3% of them. I don't think I've ever knowingly eaten a dud peanut M&M. Have you?
You're not eating enough M&Ms, Elliot.
I clearly am not eating enough. You really have?
Yeah, definitely.
Oh, so I didn't even know what he was talking about, but maybe eat more peanut M&Ms.
Yeah, but I've done the weird things to experience the peanut M&M, right? Like you can suck on it until the candy shell is completely gone, which is fun, but then you can keep sucking on it until the chocolate's gone and you end up with a peanut.
Right.
Like there's all kinds of quirky things for this. So like the experience of eating peanut M&Ms is part of why I enjoy them.
Okie dokes. Well, the experience of watching this machine build is what made me hungry for peanut M&Ms. No, it's a really cute idea. The idea is that chocolate and peanuts have different densities. So if you can figure out how big the peanut M&M is on the outside and then weigh it, you can hope to figure out whether it's all full of chocolate or whether there's a peanut stuck in there. It turns out peanuts are denser than the chocolate they use in M&Ms, which was kind of totally surprising to me. How do you measure the size/volume of a peanut M&M without destroying it? The answer is a rotating line scanner. This is one of those where you put a laser line offset 45 degrees from a camera, project it onto it, put the peanut M&M on a rotating plate and turn it slowly around. You watch the curve that the laser line looks like from the camera's vantage point, and as it goes around, that maps out the surface. This is a great old trick for doing 3D scanning on the cheap, and a whole bunch of rotating platter, small things 3D scanners use it. It's really cute to see it done here, and he actually explains it really well in the video. Then a little arm comes and kicks the peanut off to get weighed, and then decides whether it's heavy or light.
So I think it's manual place though, right? You have to put the peanut there, the M&M there in the first place.
Yeah, you have to open the top of the case. You have to put the M&M on the little rotating turntable, and then you have to close the case back up so that you don't get like stray light hitting it and messing it up.
And then I see a PC fan in there, and I don't remember him mentioning that. Is that because the stepper motor and the driver are going to get warm and melt the chocolate on the peanut or on the M&M?
They melt in your mouth, not on your hot stepper motor. No, that's for the Raspberry Pi that he has doing the hard lifting of running the OpenCV and stuff. It's actually not for the M&M at all.
Got it. Okay.
Sorry, man. But good idea. At the end, it comes down to he calculates the density and then has like a threshold cutoff rule to kick it one way or the other. And he ends up being right about 75% of the time, which isn't really all that good, seeing as it's a binary choice, right? So he'd be right 50% of the time just by flipping a coin. But still, he makes the point that in the end of the day, this brings up the concentration of peanutless M&Ms from 3% to 10% after a round of sorting. And I guess I kind of buy that. But it makes me wonder if there isn't a lot more information he could bring to bear on this. Like, are the peanutless ones smaller? So maybe if you see a smaller one, or are the peanutless ones rounder because they don't have the oblong peanut in them stretching them out? So like I bet you could combine a bunch of these factors, all of which he knows because he's got a full 3D model of the peanut M&M. So he could probably do some kind of really clever multi-factor thing where you say how oblong is it, how big is it, and then what's its density look like. And you could probably combine all these to get a lot more accuracy. I think there's much more research to be done on separating peanut-free M&Ms.
It's almost like refining uranium, Wouldn't you think you could bump the threshold down so that you're getting more false positives but less false negatives, so that all of the chocolate only M&Ms are getting shunted to one container? and then throw out your peanut-filled M&Ms and take the chocolate ones and run them again.
And I was thinking about running it twice, like you suggest, but my guess is a second trial through it isn't independent. I bet you have peanut-free M&Ms that just look like they have a peanut in them, or they have extra candy coating on them, so they weigh more, and so they look like they have a peanut in them. Even if you weigh those twice, given his really simple threshold model and what looks like a really accurate 3D mapping procedure, for what purpose? For separating M&Ms?
Yeah.
But he demonstrates it by making 3D prints in plastic of the M&Ms and putting them next to the models that they came from, and they really do look pretty good.
Yeah, I mean, it's the problem that's interesting, not the need.
You build this because you want to build a cool 3D scanner.
It's legitimate, too, to try a problem like this because, for instance, at the factory, you might want to decide as quality control, you're going to implement some way to make sure that you never get one without a peanut in it. The other thing is, like, peanuts have that natural... They come in halves, right? And so sometimes you'll get a peanut M&M that has only half of the peanut in it, which then is very likely to give you a false positive that it's
right,
or false negative, false whichever. It's going to categorize it as something that doesn't have a peanut in it because it's only 50% peanut.
Man, I wonder how he's working those into his statistics.
Yeah, I think the next step is X-ray.
I think that if this is not enough ridiculous 3D scanning for you, I was trying to think of what my favorite stupid 3D scanner is, and I thought of a while back in 2016, we ran an article on a milk-based 3D scanner where it does the same thing except with a laser line. It's got the thing immersed in a vat of milk, and it drains the milk slowly, so that interface where the milk is still covering the object and where it isn't is measured by the camera pointing down at it. I just love that because the whole device was put the thing in milk, put a video camera above it, and then put a hole in the container and let it drain out slowly. Yeah. I just thought that was so lovely. And I went to look for the article on Hackaday, and I found that it was also done before that in 2007. Milk scanner 3D mapping that's good for you and milk-based 3D scanner. I'm throwing all of our milk scanner articles into the show notes for you. The winner quote from this one is, "The object gets soaked in milk, so it won't work for scanning sandcastles. It's optimally suited for chocolate chip cookies, however."
Regular listeners of the show will recall last week when Roger Cheng wrote about a really awesome tendril robot actuator that came out of a robotics conference, and he's still on that beat. And I'm really glad that he wrote this one up called "One Wheel is All We Need to Roll into Better Multirotor Efficiency." This is a 2-propeller multicopter. So normally you would think of like a quadcopter having 4 propellers, and depending on how fast those propellers are spinning, you can move anywhere in 3D space. It gets a little more difficult when you get into 2 propellers, and we'll get that in a minute because I think that is an interesting part here. But the innovative thing for this one is it has a little tiny wheel the size of a US dime on the bottom of it. It adds a minuscule amount of weight. They said 1% of the weight of the craft to add this thing, but it allows them to kind of land and perch the majority of the weight of the quadcopter on that wheel and still drive along forward with it, saving something like up to 77% of the energy that it would have taken to fly this quadcopter if you're on a flat enough surface that you can roll on it. It's pretty clever.
So I know you're going to talk about the 2 propellers and how it works on only 2 motors. So I'm going to let that sit for a moment, but that's really awesome. Let me just say, this thing completely confuses me. Is it a car? Is it a helicopter? And the answer is it's a car, but it's driven around by fans. So it's like a one-wheeled, self-balancing fan car. But then because the fans are strong enough to lift it into the air, it's also kind of a, quadcopter with only 2 blades. Like, what the heck is this thing?
It's kind of like Rosie the robot from Jetsons. Because Rosie was like on 1 wheel. But then it's also kind of like some Dr. Seuss mobile when you watch it like going around.
And that is what it actually is a Dr. Seuss mobile.
Yeah. So the 2 propellers, I was thinking of how to describe this too. So you can think of being on a ship. And on a ship, the seam down the hull of the ship is called the keel. So think about the keel from front to back, and then you have a propeller pointed straight up into the air on the front of the boat, the bow, and on the back of the boat, the stern. And those can lift the boat up out of the water, but it still wants to travel in the direction of the keel when it's on the wheel, because that's the direction that the wheel is set up in. The fan on the back basically balances the thing front to back so it doesn't tip towards the bow of the ship or the stern of the ship. But then they're both mounted on servo motors that can rotate what are the left and right to port side and to
port and starboard
and to starboard side. So they could left and right, they can rotate in order to change where the propeller is pointing. Yeah, so I have a link in here too for a previous bicopter that shows you better. And that bicopter, it doesn't have independent tilting of the rotors. Both rotors can either tilt forward or back. So it's just your change of center of mass on that one. But this one, they are independently rotated.
And then how it keeps from falling over is that they can turn sideways to keep the thing balanced. And so it's a weird motion problem.
It's like leaning on a motorcycle, right?
It's like nothing I've ever seen is what it's like. It's like a unicycle where you have two leaf blowers, one in each hand. No, it's not like anything, dude. It's like the craziest device ever. So
why is the real reason. And
the
interesting point here is they have a LiDAR. This is built to carry LiDAR. So it's a very small craft. It's supposed to map inside of structures. The LiDAR is only blocked along one plane, straight up. It gets very close to a good 360-degree view of the room because of the linearity of the aircraft.
What this is a kind of a delivery vehicle for a LiDAR, and one that can use a low energy output mode that is kind of rolling on the ground to get to where it wants to take off, fly, and do its actual mapping, so that you don't waste a lot of the energy flying around to where you want to go in the building before you pick up into the air and start mapping. And I think that bit's clever, because what limits quadcopters these days is absolutely the fact that they're completely inefficient. If you want longer flight time, you have to put heavy batteries in, but then you have to lift the heavier batteries because it's a quadcopter. And so, you really run into trouble with helicopters in general. And I think what they're trying to do is kind of nick away at that problem a little bit by having it be able to run on the ground, while simultaneously not making like the landing gear and the car aspect of it so heavy that you can't lift the damn thing into the air again, because really this is a copter, not a driving vehicle. It's just a copter that rolls sometimes. Maybe I've solved what I think this thing is. I'm still not sure I buy it. This next project is one that answers a question that I've had for a long time. And my question is, why aren't people using cell phones more for their devices, for their robots, for whatever? Because they've got gyros and screens and cameras and a beefy processor and wireless and, everything you need for robot brains in it. Matthias Müller and Vladen Colton have taken this up in their open source self-driving smartphone robot. I think this is a really neat project in a lot of ways, and I got some bones to pick with it, so it's kind of a love-hate thing. I'll go through it all. I think it's an awesome project. What they've got is a cheap 3D printable frame using kind of normal, I guess they're those GM4 cheap Chinese gear motors, and normal wheels plugged up to a standard motor driver, plugged up to an Arduino. So the whole kind of robot frame body part of this is dirt cheap, easy to get in modules on eBay, and basically buildable by anyone. The gimmick then is that the Arduino talks to your cell phone by plugging it into the USB, and it talks a serial protocol that they've worked out so that the smartphone can drive the Arduino that then drives the motors, talks to the sensors, gives the information back to the smartphone. What I really like about this is that they've unified this in a way that makes it work tremendously well together. The smartphone apps handle all the heavy lifting, the Arduino handles all the real time, and they talk to each other over a serial protocol. The main selling point of this is that they're also doing a kind of AI neural network based navigation inside buildings with this thing. That's where it gets both really interesting, but it also kind of undoes their "this is the cheapest robot" premise. because they want to say, look, we've made this $50 robot, just add a smartphone. But at the same time, you have to have a smartphone that's capable of doing the like real super huge number crunching, especially parallel number crunching that these deep vision models require. And what it means is you have to have a smell phone. What it means is you have to have a cell phone that's kind of only 2 years old. So you're not going to pick up the cell phone out of your junk bin unless you're a real cell phone addict and put it in this thing. You're going to have to go out and buy one. And that adds somewhere between $200 and $800, of course, to the purchase price. So in that sense, I think they're fudging a little bit on their numbers by using a cell phone. But on the other hand, I guess you can always just unplug the cell phone, pull it out of the robot, and use it as your cell phone again. So maybe it is true that they shouldn't be counting that as part of the budget of the robot. I don't know. Anyway, what's really cool is that this does make Intro to Computer Vision on a real embodied robot affordable, easy, and a kind of streamlined package for people to mess around with, given that you've already got a fairly high-end, medium-end, high-end modern cell phone.
Yeah, I think this is an area that is really clamoring for a solution. And this one's not awful because it includes a portable power source and a really great camera and processing power in it. But the downside is, like you said, the cost of the phone, especially if you look at the other players in this market. So you have things like the BeagleBone AI board, which came out last year, is looking to specialize in this, but it doesn't have a built-in battery, doesn't have a built-in camera, so you got to solve those. And in the same boat would be like the new Jetson Nano that just came out, that is the lower price with a few hardware changes, but I think definitely it's going to keep up with the phone. You have to run an Android app. And so you're dealing not only with the microcontroller coding that you have to do to make the hardware end of it work, but then you have to figure out how to, stand up the Android app and compile. I mean, they've already got the example there, but it means that you need to be the master of multiple languages and multiple tool chains in order to get it to work. And I think that starts to take it out of the beginner's realm of robotics.
And that's where I think this kind of target audience versus design choices mismatch comes about. If you were really serious about computer vision and really serious about robotics, this would all be done on some platform that can run Linux for the computer vision side and has a GPU for the AI side, probably runs robot operating system ROS on the robot side, because those are kind of the three state-of-the-art technologies that you will want to be learning if you're going to get really serious into self-driving vehicles or whatever. Whereas this doesn't use any of those three. Instead, it goes the other way and lets you play around with the AI side of things, lets you play around with the neural network side of things a lot more and a lot cheaper, but then the cost of getting in so cheap on that side is that you don't get to play around with a good robot operating system. And like you said, you have to code in Java for Android instead of C++. And that's where it gets a little bit less appealing. On the other hand, how many hands do I have? On my 17th hand here, what I really love about this is I went through their GitHub and looked at their Arduino code, and the idea of the kind of the serial protocol they have that talks between the Arduino and whatever brain it is. In this case, it's a cell phone through USB, but could be anything else that speaks serial, is kind of interesting. And maybe when you're ready to take that next step, you could put a non-Android single board computer into the robot and work it that way, or transmit the serial wirelessly and just completely remote control the thing and do the heavy lifting on your desktop. Or, I think there's a lot of options here, and it definitely solves the how to integrate a smartphone into a robot problem in a nice, clean way. And so for that alone, I really like it. Myself, if I were rebuilding this, I think I would ditch the whole AI thing and not even worry about that, and just worry about writing cool Android apps to control the robot part of it, to make use of things like, the gyros and the IMU and the camera and whatever else is on the bot. And I think this is a great platform for doing something, in a sense, a lot less ambitious. And maybe these less ambitious goals also fit the capabilities a little better too. So have a look at it. I bet you'll be fooled into putting a cell phone into something. I don't believe that at all.
I don't either.
Have a look at it if you're interested in trying to integrate a smartphone into your next robot project.
Yeah, man, I've written smartphone apps. It's
horrible.
not worth it. Yeah, it's not horrible, but it's its own whole thing that you just don't need to bring into robotics.
Yeah, but what's more frustrating is trying to get, a native Linux on the cell phone, because then none of the drivers work.
Well, I thought about mentioning this when you were saying it, though, because PinePhone 64 is a Linux phone.
Ooh.
And it costs $149.99 to $200, depending on which one you get.
All right, then.
So there's your options for this.
All right, then.
All right, so we had a hardware show and tell on Friday as part of Remoticon. It was way after Elliot's bedtime. I'm sorry, Elliot.
Okay.
But one of the people that showed off an awesome project was Andy Geppert, who we've looked into for his work on magnetic core memory boards for you to learn what magnetic core memory is all about and play around with it. And his newest one is looking so nice. The hook that he has for his projects is it's not just the core memory, which is, a grid of wires that really doesn't do much. You look at it and say it's a grid of wires. Look at that. But when you go to use it, he has put a grid of LEDs below it. And so the microcontroller that's monitoring the core memory will light up an LED right below the ferrite core on the memory whenever there's a 1 stored there, which makes it a lot more interesting for user feedback. But then the really cool gimmick is he's constantly scanning the matrix. And so if you put a magnet near any of the cores, you can turn them on manually because it'll scan it and it'll interfere with the scanning and it'll read it as being a 1. And so you can set them up, which is very cool.
Yeah, the idea of putting LEDs that show the state of the cores behind it is really super, because magnets, how do they work, right? It's invisible, creepy stuff going on. And, how core memory really works is even creepier, right? You're putting heavy pulses through these things and playing with their hysteresis to leave them flipped into one state or the other. There's, some physics that's just above my pay grade going on there. I can describe it to you, but I can't tell you why it does that. And displaying what it does anyway, at least with LEDs, is marvelous to see.
Yeah, so I'm glad you brought that up, because I went back to look it up again, because I'm the same way. I'm like, the physics behind this, how does this work again? And that hysteresis is very cool because it is almost like a magnetic latch. So these ferrite cores will change their magnetized polarity if you get to a certain threshold of current on a wire going through the center of these coils. Once you do, it kind of flips over, and then when you take the current away, it'll fall back into the rest state of the other polarity. And it's kind of like a circular pattern. I will put a video that you should definitely go watch in the show notes here that shows it off with animations really quite nicely, and even shows the hysteresis plot on the patent application for core memory, which I thought was awesome. In this case, the beauty of this grid is amazing, and that is because Andy used a 3D printed template in order to get the wires going. And so you have 8 vertical wires and you have 8 horizontal wires. And wherever they cross, there is the O201 component equivalent of a tiny, tiny, tiny ferrite core. So small that I can't believe he was able to get 3 wires through this. And the way that these work are, each wire has enough current for half of that hysteresis threshold. And so if you have a column that you turn on, 8 cores are going to get that current, but it's only half of what you need to change. So then you have 8 row wires. So you turn 1 row wire on, and 8 of those cores are going to get half of what they need to change. But where the 2 wires cross, those 2 halves add up to a whole, and it will change that. In this case, there is also a single sense wire that is going through all of them, kind of diagonally. And when you go to check which state the bit is in, you actually need to flip it. You need to try and reverse those 2 wires that you had, and you watch the sense wire to see if the bit flipped, and that will tell you if, it was a 1, and we just flipped it back to the 0, because you'll see a pulse in there. We better reprogram it again. The interesting thing is that because Andy is trying to do this thing where you can change it manually, he's actually scanning these and resetting them all constantly all the time, which I think is an interesting take on it as well. This is persistent memory though, so once you turn the power off on core memory, it should keep its state until the next time you want to read it.
You said these are really small, but imagine this was back in the day and you actually needed, kilobytes of these things instead of 8 by 8 64 bits, right? Imagine you needed a kilobyte card of these. That thing was an array with, 1024 times 8 of these things on it. Yeah, they can't be too big.
I was actually at the Open Hardware Summit a couple of years ago, and the keynote speaker, I forget her name, but she was talking about technologies and how they pull in skills from other areas, and was talking about core memory and saying that when they were making large arrays of this, especially for the space program, they were pulling in people from the textiles industry who had experience in weaving in order to figure out how are we going to manufacture all of this memory that we need in order to make the mission successful.
Well, if core memory is slightly too old for you, how about you store your memories on cassette tapes? This is a modern take on storing data on audio cassettes, proper cassettes for your FPGA retro computer by Z. Pekich. I have a certain weakness for the kind of bleepy bloopy noises that data stored on cassette tapes makes. And in this project, he's recording data out to cassettes from an FPGA and reading them back in. It's a nice little dive into a technology that is fortunately long forgotten, but I still think is cool. It's really kind of fun to think of computer data and audio as being the same thing. And the way this does this is frequency shift keying, which is to say he picks two different tones, one high, one low, and one of them is a 1 and one of them is a 0, and records these on the tape. And then to read it back in, of course, you do the opposite. You have the computer / FPGA listen to the tape coming in, figure out if it's a high frequency bleep or a low frequency bleep, and then assign it a 1 or 0 accordingly. There's a whole bunch of interesting ways to do this, including, fast Fourier transforms is the dumb way, the Goertzel algorithm is the right way, and then the way he's doing it, which is to just try to time the 0 crossings in the waveform as it's coming in. And so he's got an ADC on the front of the FPGA. It's a DC blocked on the way coming into the ADC, and then he just counts how much time it takes for these waveforms on the cassette to cross the 0 line, and that tells him, of course, what frequency it's coming in. Reads these out, 600 bits per second, 8 bits, no parity, 2 stop bits, and boom, he's able to read and write data. He stores it out by writing square waves out of the FPGA and then kind of low-pass filtering them on the way out, on their way to the tape machine. So it's kind of it makes these kind of almost distorted sounds, but all that matters is the frequency of these distorted sounds and its ability to read them back in. So works.
I think that this is kind of beyond me and how they all got it to keep going. It seems like it'd be a difficult problem to maintain the timing.
Yeah, right? And it is. And tape is horrible because tape players have like wow and flutter, which are two different names for the same thing, which is the tape playback is never at exactly the same speed. You can kind of hear it in old cassette tapes. They go, woo, 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 woo. And woo, woo, woo is exactly what you don't want if you're encoding data in pitch. So what he does is, of course, he uses two pitches that are really far apart, and that helps with the discrimination. I think if you go back and look at these old standards, though, there's some tricks he could pick up. Like, you know how they always used to make that squawky noise in the beginning? They were putting out sync tones so that the decoder could lock onto it. And he doesn't do that at all here. He just saves the data straight out to it and reads it straight back in. So there's actually some strange refinements he could go into here. And if he wants to get into error correction stuff, we've learned so much about error correcting codes and, how to pack bits better and things like this since the bad old days. I think he could take it even further. And Elliot in the comments pointed us to our vid, which is a similar system coming out of Russia in the 90s, except it's storing it on VHS tapes. and they got a staggering 2 gigabytes per VHS tape by
Wow.
doing something very similar. And this was mid 90s. There's even higher densities you could probably push this to with modern technology. I think this is really interesting. And I want to close with the reason I think it's the most interesting, which is that if you take data and turn it into sound, you can then just broadcast it in any of the ways you can broadcast sound, which include how you're listening to me tell you this right now. And an old radio station in the mid 80s in Belgrade, Ventilator 202, actually broadcast code. They broadcast video games and other things back when there was no other real way, except I guess maybe BBS's, but I think there wasn't so much of a BBS scene in the former Yugoslavia. They actually were broadcasting code over the radio waves on a radio station to people listening to them. And this project was done in the memory of Yugoslavian broadcaster Zoran Modli. And I just thought that was super awesome. And this guy is a crazy, mad hacker. It's like, you don't have a distribution method for these video games. What are you going to do? And the answer is, put them on a radio station.
I think it's brilliant. I mean, you have the one piece of infrastructure, the transmitter. It's already being, it's already there being used for other stuff. Why not use it for this? What about the original hardware for inputting tapes like this? Was there like a hardware that would lock on and do the signal timing, or was that being done in code?
Oh, I think it was all done in hardware. And
Yeah.
if you want to look at this, go into the Kansas City standard. I'll throw a Wikipedia link into the show notes here. There was actually some really clever stuff done back in the day to make all of this decoding in particular doable on bare chips rather than any of this code. So completely done in hardware.
Well, that's why I asked, because this is an FPGA program, or a project. So you should be able to get the schematics from the vintage equipment and then re-implement it in HDL.
Oh, right. Yeah, you could do a 1-to-1 just
Yeah.
straight out of the old machines.
Yeah, I mean, I know
that'd
the
be
challenge
super
is
fun.
to re-implement it yourself with modern equipment,
Yeah.
but it just strikes me that I would think someone's done it. I would think you could go download an FPGA course somewhere that has the re-implementation of some of these tape drive circuits on it, which would be an interesting exploration.
This is one of those ideas that keeps getting rediscovered, and I think everybody should dig into at least once, just because it's a useful, if quirky, tool to have in your toolkit.
First up on my list of quick hacks is getting over 4 gigabits per second out of a Compute Module 4. Jeff Geerling has been doing all kinds of fun stuff on the new Pi 4 boards that have come out. And this is the latest project that he has tackled, which is to plug in an Intel 4-part gigabit Ethernet card into the PCI Express connector that comes on the host board for the Compute 4 module. Wow, that is a mouthful. The story goes kind of deep on this one, and it ends with compiling your own Linux kernel, and I think this is where most people's interest will end up being. This is a really good guide on how to cross-compile the Raspberry Pi 4 Linux kernel from your computer. So if you need to do that for any reason, check out Jeff's guide. Next up, we have teardown experts sing praise of stretch releasing adhesives. So I would know these as the brand name Command from 3M. It's like the command hooks, where you can stick them to the wall and then you pull this tab and it stretches out and all of a sudden the glue is gone. Apparently these things are starting to show up inside of cell phones, for instance, to glue the battery down, because if you ever tried to replace one of these batteries, it can be really hard to get the adhesive to come off, and you don't want to pry on those lithium cells. I find that interesting, but more so, I went out and looked because I'd like to just get a roll of this tape to use for all kinds of hacker things. Has anybody seen that? If you have, write the tips line. And finally, Door mutes microphone to prevent remote learning humiliation. In the age of work from home, this is actually a really clever idea, which is just take a little magnetic door sensor like you would use, to make the bell sound on the front of a shop door, and put it on your office or bedroom door and connect it to a USB device that will hotkey mute your mic, so that when someone walks in, you can have a conversation with them without everyone on the call knowing that there's been a disruption.
All right, my first quick hack is Sebastian and Carl Johan are two architects, and they thought what would it take to build a lunar lander habitat where two people could live indefinitely on the moon? And where should we test it on the Earth? And they actually build this thing. The article is Lunar Ark Boldly Goes. They've set it up in Greenland, which is super cold, which is important because the moon is really cold. It is a really interesting shape on the outside of this thing. It's folding in an origami way so that it kind of can pack up small for the trip up to the moon, and then unfold. It inflates up to kind of 5 times its interior volume when it unfolds. But inflates is wrong because the thing is covered with solid solar panels, which they're going to need up there. They are dogfooding their project right now, writing logs every day. Since the sun has gone down permanently for the winter up there, half of their posts have included the word cold, and my favorite of them is, "It's so cold now that the bottom of the hab is freezing," which is where the toilet tank sits. When Seb found out, he looked at me and said, "You're in big trouble."
Oh.
Next up, help, I'm buried alive by tablets. Mike Drew has picked up a bunch of reject/refurb, probably Windows tablets of probably 5 or 6 year vintage, and is wondering what to do with them. Go drop him a suggestion in the comments section if you know what he should be doing with these slightly underpowered but peripheral rich devices. He's got a lot of them. You'll note that a lot of people think, what would I do with one? But he's got 20 or 30. Finally, Daniel Cooper wrote an article that showed up in Engadget. Connect gave us preview of a future, though not the one it intended. And Roger Cheng wrote it up. I was a little bit disappointed in this one, but I think you should all go read it because the Connect is the awesome 3D camera that spawned a bunch of really interesting hacks. I know in our hackerspace, we used it to make a robot that could see things in 3D spaces by like basically tacking a Kinect on top of a Roomba. This article goes a different way and talks about the gaming aspects of it, but I am willing to pay my respects to 10 years of the Kinect for all of the great hacks it's actually inspired.
Next up, we have Can't Articles of the Week. This is the long-form content written by awesome Hackaday writers. Elliot, you're up first.
Okay, my pick this week is Prism Lighting, The Art of Steering Daylight, written up by Moritz Sievers. This one actually came at us through the tips line, but answered a question that I didn't even know I had. If you think about like an old-timey store in America, a lot of them have these kind of elaborate glass. They look like normal glass bricks on top of the main shop window. And I'd never thought about them until reading this comment where it was pointed out that they're Luxfer prisms. And these are little prisms. It's basically like a flat linear Fresnel lens that bends the light as it hits them. And the idea is, instead of the sunlight just passing through a normal glass window and ending up on the floor right by the front door, these bend the light up and direct it back at the roof. So you can light up the way deep back of a store just by sunlight, just by capturing the light and redirecting it upwards. And I thought this was so awesome, kind of environmentally friendly and just interesting as a technological solution. And then what happens? The light bulb appears, and making light indoors isn't a problem anymore. It becomes really easy. And so this incredibly complex and, difficult molded glass thing goes away and becomes forgotten until it shows up again in the Hackaday comment line, and Moritz ends up writing a great article about it.
I had always been under the impression that a prism separates the colors of light because that's the only firsthand exposure I've had is like in physics class doing those experiments,
Right?
which are very cool. And come to find there are many different types of prisms, and reflecting light back at specific angles is one of those where it doesn't separate the bandwidths. It keeps the light very nice and natural like it is, but it directs it somewhere that's more useful. And that's really cool to see it happen. But then to think about, the architecture side of this and how we're talking about buildings that should be net zero and really thinking about, what the lifetime expense of running a large piece of infrastructure will be, designing some of these into our modern windows could have a huge benefit on this. And the greatest thing is like the operation of them is no harder than operating a window shade, right? Like if you want it to be darker in your room now, you put the window shade down. So if you have a window that is using some of these prismatic features on part of it, in like Elliot said, in order to reflect light across a wider swath of your ceiling, so then your ceiling is radiant, you can adjust that by making it so only part of the ceiling is getting it or none of it at all. It's a passive thing that is, I guess, intuitive to control, and the user doesn't have to know anything about it. And I had no idea this has existed for a long, long time. Great topic.
And then the modern great-great-grandchild of this, what's old is new again. LED diffusers are starting to use plastic, super thin, prismatic reflecting screens to better spread the light out. If you think about an LED, they're these like really harsh point light sources, right? And if you think about an LED light that's installed in your ceiling, it's shining this harsh point light straight down at all the poor people. So if you look up at it, oh, dude, you're blinded. That's not cool. If only there were a way to turn the light at the edge of that fixture. And turns out that architects are turning back to this idea of these turning prisms, but now you can make them out of super thin plastics and do the same thing. So instead of the LED shining directly down at you, you can spread it out in an almost completely horizontal way outside of the light fixture. And if you've ever taken apart an LCD screen before, you've seen one of these, because there's that, there'll be like a milky layer and then there'll be another white layer. I don't know why there's so many diffusers. And then there'll be this funny one that has creepy optical properties. And if you haven't taken apart an LCD screen to get these micro prism sheets, you absolutely should. They're really awesome. If you look at it closely enough, you can see what it's doing is diverting the light beams that go into it at kind of like 30 degrees either to the left or to the right. And so the fun thing to do with them is shine a laser beam into it. And you'll see it splits off into two other laser beams on the other side of it, making a Y. And if you imagine it doing that with every beam of light that goes through it, you can see how this is a useful thing inside a diffuser to kind of break up the otherwise strips of LEDs or compact fluorescents or whatever it is that's inside your monitor. That's another great use for them, and surprisingly very similar in miniature, of course, and in plastic instead of glass, to these old Luxfer prisms. And I just think that's lovely.
All right, I picked another awesome write-up by our own Elliot Williams. This is the Raspberry Pi 4, but it's the most recent flavor, the 400 keyboard, put to the overclocking test and then pitted against its fellow Raspberry Pi 4 line, the Model B and the compute module. I think the key takeaway for me is I didn't clue in to the fact that the same chip is on the CM4 and the 400. So the keyboard version and the compute module version have the same chip, which is one rev past the Model B. We might have talked about that before, but they're clocked at different clock speeds. So the compute module is still clocked at 1.5 gigahertz, but the Model 400 is clocked at 1.8 gigahertz, which is a head scratcher. Like, why wouldn't you clock them? And it all comes down to the operating temperatures when you clock them up in speed.
I haven't overclocked a computer in, probably 10 years now, but that's what got me looking into this, is I noticed that there was a different version number and there was a hint that there was better thermal management in these newer ones. And then the Pi 400, the laptop one, the one that's built into a keyboard, really literally has this big aluminum heatsink, but it's completely encased inside the plastic keyboard. And I'm wondering, how does this thing throw off the heat, and how is it still that it's running faster? So I went to look into this, and it turns out that that heatsink combined with the slightly more power efficient revision of this chip means you can clock that thing at full speed all the time, just for fun, just because you want to.
Yeah, so we put this on Slashdot today, and of course the first comment is a detractor saying, You said you had upped the speed to like 2.2 gigahertz and it wouldn't boot. And so then
Yeah.
you backed it down to 2.15 gigahertz and it runs fine for hours on full core usage. And that person was saying if it's unstable at 2.2, then you can't run it at 2.15. And I think that's a
Why?
fallacy. I'd like citation needed, right? Like,
Yeah. Why?
so,
I
yeah.
did.
Yeah. So, any idea why it would not want to boot at the higher clock speed? Is there a timing thing with the chip bring up, or what do you think is at play there?
Let's see, there's two things limiting the speed of a Raspberry Pi. And the first one that I'm looking at here is thermal throttling. That is, there's a little governor. It actually is a separate RISC operating system that lives in the GPU. I learned so much about Raspberry Pis. That looks at the temperature all the time, and when the temperature gets too close to 85 degrees, which is its absolute maximum, so when it gets up to about 82.5 degrees C, it turns the clock down on the CPUs and runs them slower until it gets cool enough that it can run them faster again. And it does this, within a second. It does this at an incredibly high frequency. And this keeps the chip from overheating, even if it has no heat sink, even if it's running, covered up in a small box in the summer in the sun. It won't overheat. What it'll do is it'll just throttle the chip down to lower and lower speeds until it can make it without driving itself into any kind of thermal meltdown or whatever. So that's the first thing that limits the speed. And that's what I was interested in this article, because that's kind of what practically limits you from overclocking a Raspberry Pi, or at least so I thought. But it turns out that these new chips are efficient enough, and if you put a big enough heatsink on there, you can run it fast enough that the silicon just can't keep up. And I think that's what this 2.2 gigahertz-ish threshold is. And it's funny, we got a comment from Jeff Geerling who said he has actually managed to get one clocked up to 2.2 gigahertz, but not all of them. And so I think in the end, this is just, slight differences between the silicon in one, where it's like 50 more kilohertz here or there is where it really hits that ragged edge where, the electrons just don't move around fast enough or whatever. But that effect is likely to be completely independent from heat, because when you're overclocking it too far, the thing just doesn't even start up. So it can be at room temperature and still won't run. Maybe you can give it more voltage and have it run there, but you're going to void your warranty. And, you probably... Look, it's a Raspberry Pi. It's not a supercomputer. Like, you can try to push it as hard as you can, and it's still not going to be a supercomputer. Even if you get these extra 50 kilohertz out of it, it's not going to be a supercomputer. So overclock it as far as you can, as far as is safe. Take what you can get, and, bonus, right?
Your takeaway is that the 400, the keyboard variant, is going to be fine left at 2.15 gigahertz because it has those governors in it that are going to cool it down. But the stock heat spreader was so good that you don't even think you're going to have to face that, right?
Oh, it doesn't even get close.
Yeah.
I left it running at, I was doing a bunch of different tests, right? Cranking its speed up and seeing how hot it got. And even overclocked at 2 gigahertz, it doesn't even start to get what you would think of as hot. And so I jumped it up as far as it would go before the thing blacked out and just let it run for 3 hours on my desk. 3 hours, CPUs, all 4 of them, absolutely 100% maxed out. Like, they were doing small matrix multiplications, which mean it doesn't even have to fetch in new data from the memory.
Right.
So it's all done within the cache. So it's really putting the absolute maximum load on the CPUs to make as much possible heat as you can. And even so, it sits at kind of 62.5 degrees long run, and that it only reaches after about 45 minutes. If you're using these things as a normal desktop or as a normal computer that gets these periodic peak loads, I would have absolutely no hesitation of running the Pi 400 or even the compute module with a decent heatsink on it up to as high as it'll go, because you're probably never even going to see the thermal throttling effects. I was frankly surprised. I took the Pi 400 apart in my teardown article and I'm like, It's a big hunk of aluminum, but it's a big hunk of aluminum inside a plastic case. How is this going to radiate the heat out? And so you've got, it's the race, right? It's like a really giant heatsink, but it's a really giant heatsink in a box. Is this going to work? And so the answer is, yeah, it totally works. It works incredibly well. And I can't see any reason not to just run these things full out all the time, because if you need the power, you'll have it. And if you don't need it, they also throttle down when they're not under load, so it won't eat up the extra juice.
That's all the time we have for this episode of the Hackaday podcast. As always, we'd love to hear from you. You can leave a comment in the show notes, which you'll find at hackaday.com/podcast. You can email us, editor@hackaday.com. We live and die by the tips that you send in, so if you've done something cool or you see something cool, let us know. tips@hackaday.com. And until next time,
keep on hacking. All right. Hold on.
Like your clicking is extra loud, and then it sounded like you were moving furniture. I don't know if
What's that? Yoicks.
I don't want to say it if it's wrong, so we're just not going to say it.
Right, we're done with this anyway. Yeah, look at that. Look at these segues. They're just happening, man. I've said cassette tapes too damn many times. Oh yeah, one more time.
Do you get it? Ba-dum-bum-bum.